Alice, Bob, and Eve explain quantum random numbers.
Help me shuffling this deck of cards. I need a truly random card for our game, but I've been practicing card tricks so much that my shuffles might not be completely random anymore.
That's actually a great segue into talking about quantum random numbers, one of the most practical applications of quantum physics.
Quantum random number generation is fascinating. It's one of the few quantum technologies already being used commercially today.
How are quantum random numbers different from regular random numbers?
Classical random numbers, like those generated by computers, are actually pseudo-random. They're produced by deterministic algorithms. If you knew the starting state, you could predict all future random numbers.
It's like your card shuffling. If someone tracked every movement of your hands and the cards, they could theoretically predict the final order.
So quantum random numbers are truly unpredictable?
Exactly. They're based on fundamental quantum indeterminism. When you measure certain quantum systems, the outcomes are not just unknown, but fundamentally undetermined until measurement.
Think of these bouncing balls I got here. Classical physics says if I knew the exact position, velocity, and all forces acting on each ball, I could predict where they'll be in the future.
But quantum particles don't work that way?
No, they don't. Take a simple quantum random number generator that sends photons through a beam splitter. Each photon has exactly 50% chance of going one way or the other, like a perfect coin flip.
But unlike classical coin flips, which are determined by physics we just can't track precisely, the photon's path is truly undetermined until observed.
How do we know these numbers are truly random?
We can run statistical tests to verify they pass randomness criteria. But more fundamentally, quantum mechanics tells us these processes cannot be predetermined. Einstein called it spooky because it challenged his belief in a deterministic universe.
Many modern devices now incorporate quantum random number generators, tiny chips that use quantum processes to generate unpredictable numbers.
What are these random numbers used for?
They're crucial for cryptography and cybersecurity, creating encryption keys that cannot be predicted. They're also important for scientific simulations, fair gambling systems, and even randomized clinical trials.
Some online casinos now use quantum random numbers to ensure their games are truly unpredictable.
So no matter how perfectly I shuffle these cards, I can never achieve the true randomness that comes from quantum processes?
That's right. And that difference isn't just philosophical, it has practical security implications. A truly random key cannot be guessed, no matter how powerful the computer trying to crack it.
The fascinating thing is that quantum randomness isn't a bug. It's a feature we can harness to guarantee unpredictability when we need it.
I guess I'll stick with my shuffle for our game, but next time we need to make a truly random decision, we should use quantum technology.